Welcome to enrichment video for Unit 3, Lesson 3. We're going to prove quotient rule. I'm going to show you two proofs. The first proof relies on the product rule, which you learned in 3.2, and chain rule, which you'll learn later. But a very quick overview of chain rule. Of course, we'll go into detail on chain rule later. But what we're using chain rule to do is we're saying that if f of x is, say, 1 over a of x, just as an example, I'm going to not use a actually, let's use some g. So f of x is 1 over g of x. Okay. Then, which is equal to g of x to the negative 1 power. Then the derivative of f of x is going to be we're going to use the power rule again. That's just negative 1 times g of x to the negative 2 power times the derivative of g of x. We'll see why this is true later. To simplify this, that gives us negative 1 over g of x squared times g prime of x. So we'll be using this rule to help us prove quotient rule. Okay. So here's the proof. Let's say that f is a divided by b. So in other words, f of x is a of x divided by b of x. To simplify it, I'm just going to write f is a over b. That's equal to a times b to the negative 1 power. Now, when we find the derivative, we can apply the product rule, where we have a for one term and b to the negative 1 on the second term. So f is really just a times b to the negative 1 power. So applying the product rule, f prime, the derivative of f, is going to be a times negative 1 over b squared, that's coming from the power, negative 1, times the derivative of b of x, or just b prime, that comes from chain rule, plus a prime times 1 over b. In other words, if f is a over b, then f prime is a times negative 1 over b squared times b prime plus a prime times 1 over b. To simplify this further, that's the same as negative ab prime over b squared plus a prime over b. I'm going to multiply the second term by b on top and bottom so we can add the fractions. That gives us negative ab prime plus a prime b over b squared. Rearranging the terms gives us a prime b minus ab prime over b squared, which is, again, low d high minus high d low over the square of what's below. So that gets us the quotient rule. Okay. This proof is easier to understand if we understand the chain rule. We can also figure out the quotient rule. Here's the second proof, just right off of the definition of derivatives as a limit. So here's the second proof. Remember that the derivative f prime is the limit as x goes to 0 of f of x plus h minus f of x over h. Well, if f is equal to a over b, I'll write this better. If f is equal to a over b, then f prime, by the same definition, has to equal, instead of f of x plus h, we end up with, I'm going to color code this. I'm going to use red for a, green for b, to be more clear. So this is going to be a of x plus h over b of x plus h minus a of x over b of x over h. When we subtract the fractions, So we multiply the first term by b of x on top and bottom, multiply the second term by b of x plus h on top and bottom. We will end up with a of x plus h times b of x minus a of x times b of x plus h over b of x plus h times b of x, all of that over h. Of course, I could simplify this. If you have a divided by b divided by c, that's the same as a divided by b times c. So I just put the times h here to simplify things. Okay? Next, to prove this, I'm going to add two terms in the middle, kind of like my proof of the product rule. So I'm writing my two terms that we already have, minus a of x, b of x plus h. But now, and the bottom stays the same. But now I'm going to add two terms. I'm going to first minus a of x, b of x. And then I do plus a of x, b of x. Of course, if I add and subtract the same thing, that is okay. Okay, so now I have the limit as x goes to 0 of four terms. A of x plus h times bx minus ax bx plus ax bx minus a of x times b of x plus h over b of x plus h b of x times h. Now on top, we can factor out a b of x on the first two terms and an a of x on the second two terms, and we end up with this. So factor out b of x. Then I have b of x times ax plus h minus ax minus, I factor out a of x, minus a of x of b of x plus h minus b of x. All of that is over b of x plus h, b of x, h. Okay. Here, I'm running out of room, so I'm going to write this down here. Same thing, I'm just moving this so we have more room. B of x plus h times b of x times h on the bottom. Well, I can rewrite this by moving the divide by h here into each individual terms as equivalent. So instead of having h on the bottom, I have on the first term on top a of x plus h minus a of x. I'm going to put the h here. On the second term I have b of x plus h minus b of x. I'm going to put the h here. Okay. But wait a minute. This term is just the derivative of a, because we're taking a limit as h goes to 0. So I'm going to replace this term with a prime. The second term is just the derivative of b prime. And as h goes to 0, we know that b of x plus h and b of x are the same thing. They're both b of x squared. So we have proved this. We've proved that the derivative of f prime of x is b times a prime minus a times b prime over b squared. Low d high minus high d low over the square of what's below. So these are two ways of proving that the quotient rule is correct. That's it.